when we measure probability, we're simply taking a ratio of what we want to happen over the total possible outcomes. So if I'm rolling some dice and I'd like to get either a 2 or a 3, there are 2 numbers that I want out of a total of 6 possible numbers. Just like any other ratio or fraction, I can reduce that probability down to 1/3, and then I could write that 1/3 as a decimal, so 0.33, or even as a percent, so 33%. When you're calculating multiple probabilities, you simply need to know that if the question says and or both, then you're going to multiply your 2 probabilities. If the question says or either, then you will add your 2 probabilities. If the question says or implies the word at least, then you will subtract the exception. And we'll talk about that more in just a bit. So in this case, the question asks us about the odds of flipping a coin heads 3 times. If I flip a coin once and try to get heads, there is 1 outcome that I want out of 2 possibilities. The second time I flip a coin, I have the exact same odds, 1 out of 2, and likewise with the third, 1 out of 2 chance of getting heads each individual time I flip the coin. But when I say I want to get heads 3 times in a row, what I'm really saying is I want to get heads, and then I want to get another heads, and then I want to get another heads. So if you're combining the probabilities and you use the word and, then you're going to multiply your chances. So I'm going to multiply 1/2 times 1/2 times 1/2, and I get 1 out of 8. So there's a 1 out of 8 chance that if I flip a coin 3 times, I will get heads all 3 times. In most probability problems, the arithmetic you'll do is not very difficult. The hardest part is wrapping your mind around the situation. In this question, they ask us, what are the odds that at least one of John or Paul passes the test? Which means we could have John pass or Paul pass, or we could have both. Now, there is a shortcut with at least problems, and I'll show you that in a bit, but I first want to show you what you could do if you did not know the shortcut. So we're going to list out the different ways that at least one could pass the test. First, John could be a yes, he could pass, and Paul could be a no. Or John could be a no, and Paul could be a yes. Or they could both pass. John could be a yes, and Paul could also be a yes. Since I used the word and to describe the situation, I'm going to multiply their individual probabilities. So John has a 30% chance of passing. I can write that as a decimal of 0.3. Paul has a 40% chance of passing, which means the odds that he does not pass must be 60%, which I can write as 0.6. Since I want John to pass and Paul to not pass, I'm going to multiply their individual chances. So there's a 0.18 or 18% chance that John passes and Paul does not. Or John could not pass. So there's a 70% chance that John will not pass, and a 40% chance that Paul will pass, or a 28% chance that John doesn't and Paul does pass the test. Or they could both pass. So there's a 30% chance that John passes, and then there would be a 40% chance that Paul passes. So we get a 12% chance that both John and Paul pass. And then since I use the word or between my different probabilities, I'm going to add my separate outcomes. So 18 plus 28 plus 12, and I get 0.58, or a 58% chance that at least one passes. Now to the shortcut. When the question says the word at least, one thing you can do is test for the exception. So instead of figuring out all the different ways that John or Paul could pass, what about the opposite? What are the odds that neither one of them pass? So if there's a 70% chance that John does not pass, and we're going to multiply a 60% chance that Paul does not pass, then there must be a 42% chance that neither one of them passes. So 42% of the time, no one passes. That means the rest of the time, at least one, possibly both, pass the test. So I simply could have taken 100% of the time, subtract the 42% when no one passes, and that would have given me, look at that, the same answer, 58%. If you come across a question that seems to be outside of the typical and or at least rules, then sometimes your only choice is to draw a picture. So in this case, we have a bank where each employee is either a clerk or an agent or both. And if I have 3 agents, one of them is also a clerk. And if I have 2 clerks, one of them is also an agent. So when the question asks what is the probability that the person you choose is both an agent and a clerk, it might seem obvious that you have 2 people who are both out of 5 total employees. So you may be tempted to answer 2 out of 5. But the trap here is this agent-clerk combo is actually the same person. So if we redraw our employees, we have an agent, and then an agent-clerk combo, and then a clerk. So we have one person out of 4 who is both.